you know, Shabab, when we have a triangle, a right triangle, these two angles, A and B, their sum is 90, because 90 plus 90 will be 180. So we can say that B is 90 minus A, or A is 90 minus B, because their sum is 90. Now look at sine, for example, look at sine A, this angle. Its sine is A over C, which is the same as cosine of B. If you see, it is also cosine of B, the adjacent over the hypotenuse. Similarly for tangent. Tangent A is the opposite over the adjacent, which is the same as cotan for B. So also the same for secant and cosecant. So what we conclude from that whenever we have two angles, their sum is 90 degrees or pi over 2, then they are co-functions. Sine equals to cosine, tangent equals to cotangent of these two angles, and secant equals to cosecant. If you put here B and here A, it is also the same, okay? So we summarize that in this way. We say that sine A, it is cosine B. What is B? Here it is B. It is 90 minus A. The same for secant, for cosine, for tan, and so on. This notation is the one that we will use mostly. The notation with the radian, the radian notation, radian measure. Sine pi over 2 minus x, it is cosine x. So on x here, it is any real number. Tangent is equals to tangent for pi over 2 minus x, and so on. Let me give you an example, and an easy example about how can we use this idea. Cosine 59, it is the same as sine 38. Why? Cosine 59, it is the same as sine 90 minus 59. This is A now in our case. Now 90 minus 30. So if you know this, you can find this. Because I told you that at the beginning of chapter 5, that these two angles are called complementary when their sum is 90. Tangent 71 is the same as cotan 19. This is an secant 24 is cosecant 66. Now let me give you an old exam question. This is an old exam question, how to find the value of this expression. How to find its value, what is it equals to? You don't know what is cosine 20 without a calculator. Of course, what is cosine 70? It is not one of the well-known angles. So how to do that, ya shabab? Any idea? Any idea, shabab? You can solve this in different methods.
Maybe 70 plus 20.
Again?
Maybe 70 and 20.
I didn't get your point. How?
Teacher,
Yes.
You can go if you want.
Yes, please.
Cosine 20 is the same with cosine 70.
Cosine 20 is the same as cosine 70. This is what you said?
Yes.
Who said that?
If we do what he said before.
No, look, this is what we said. Cosine equals to cosine pi over 2 minus x. It is the same as sine. Sine A, it is cosine 90 minus A. We said that, look, do you remember 30 and 60? 30 degrees and 60 degrees. 30 degrees and 60 degrees. These two angles, their sum is 90. So sine 30 is a half, which is the same as cosine 60. So it is not cosine equals to sine. Be careful. Cosine equals to cosine. Also, Shabab, 90 and 0. Do you remember 0 and 90? What is sine? Sine 0. Sine 0 is 0, which is the same as cosine 90, and so on. So what you should say here that cosine 20 degrees is
Isn't-
equals to sine.
Isn't this cosine squared theta plus sine squared theta equals to 1?
Exactly. It will be
One
0.
by one. Yeah, Shabab, you are jumping. You are not. This is not what we are talking about right now. You are mixing things up one by one. Let's agree about this. Cosine 20 is the same as sine 70. Now, is this correct or not?
Yes, correct.
It is correct. So when we square, of course, both sides, we still have the same identity. So what we will do, we will say this is equals to 1. This is طبعا يا شباب one way. There are several ways. You can say that this is sine squared 70 minus cosine squared 70 degrees. So this is the first step. So what we used here, we used the cofunction identities. Now you can do here many things. One way is to ask yourself, what is this? What is 1 minus sine squared? What is 1
Cosine
minus
squared.
1 minus sine squared theta for any theta? It is cosine squared theta. So this is cosine squared what? 70 minus cosine squared 70. So what is it? 0. Cosine, the same expression minus the same expression. This is one way. The another way is from here to do what? To say that this is 1 minus, take this minus and this minus, take this negative as a common factor. You will have sine squared 70 degrees plus cosine squared 70 degrees. Now 1 minus, what is sine squared angle plus cosine squared the same angle? What is this? This is 1 by the Pythagorean identity, and this is equals to 0. I wish that this is clear, Shabab. Any question about this? My target is, it was just about how to show you how can you use this. طبعا in the old exams, you can see many questions that you can use these identities in. So pay attention, special attention for the co-functions identities. Now, I think, Shabab, this is all what is remaining in what has been remained in section 5.3. I think it is now time to go to start chapter 6. And as I told you before, chapter 6, 6.2, especially 6.2, it is the same as 5.3. Almost the same, just there is a nice idea here that you will have. So what is chapter 6 about? It is about trigonometric functions from the unit circle approach. What we did in chapter 5, we have studied trigonometric functions from using the right triangle approach. Here we will take it to be much easier, and as you will see. Also, we can deal here with real numbers, not necessarily angles, of course. So we have here 4 sections, inshallah. All of them will be included in the midterm exam. Let's start one by one. Let me start with 6.2. In this section, I will remind you about what is the unit circle, how to define the trigonometric functions using the unit circle, and how to evaluate them. And we will also remind you about the fundamental identities. You know, Shabab, all of you know about the unit circle. What is it? The unit circle is the circle with radius 1, centered at the origin. This is the special name. It is unique circle. There is no circle with this name other than the unit circle. Its equation is x squared plus y squared equals to 1. Now, why this one is special, Shabab? Why we will take it? Look at this point. This point, square root of 3 over 2 and negative a half. Okay, or even a half, طبعا, if you want. Even a half also, without negative, it is the same. This point, it is on the unit circle. in the fourth quadrant. How can you know that it is on the unit circle or not? Just put x equals to square root of 3 over 2, both negative half equals to y, square both sides, square, I mean both terms, add them, you will get 1. So it satisfies the equation of the circle, so it is on the circle. If you look at this again, this is indeed, if you want to have an idea about it, it is cosine and angle, and this is sine and angle. We will see that. Let me show you what they are, for which angles they are, cosine and sine. Look here. Here you have, now we have the unit circle. Do you remember how we defined the radius, ya shabab, the radian? We said, ya shabab, if you have a unit circle with radius equals to a half, with radius equals to 1, then if you draw an angle here, theta, then this angle, the length of this arc will be equals to theta in radians. This is how we define the radian. Here it is the same. Now the length of this arc, it is pi. The length of this r is pi over 2. So this is the angle. No need to write theta, shabab. Here we don't write theta. Khalas. We mean by theta the red part here. So this is theta. This is our angle, which we call here t. So this one, the full rotation, it is 2 pi. Here when we have 3 pi over 2, here it is negative pi when you go in the negative direction. This is negative pi over 2. Look here at this point. If you take the length of this arc from here to here, you will find that it is pi over 6. The length of the arc from here to here, it is pi over 4, and so on. What is amazing here, shabab, if you find what is this point, you will find that this point, it is square root of 3 over 2.5. This point, if you find what is the coordinates of this point, what is x, what is y, you will find that it is square root of 2 and square root of 2. Similarly for that one. So if you look at this, what is this? This is cosine pi over 6. If you look at this, it is sine pi over 6. And similarly for those. Also the same idea for the point. This point, it is 1 and 0. This in fact cosine 0. This one is sine 0. Similarly here for 90. For 90 here, this 0 is cosine pi over 2. And this one is sine pi over 2. This point, it is on the y-axis, so it is 0 and 1. So here we have what is called the terminal point instead of the terminal side. So, but the idea is still the same. So what was the idea, ya shabab? Basically, indeed, we started with a triangle. Do you remember? We started with any triangle. We said that we have triangle, right triangle, and this is the angle theta. This is opposite. This is hypotenuse. This is adjacent. Then what we did, we put this triangle on the standard position. We put theta in the standard position. We put the vertex to be at the origin. The initial side is the positive x-axis. And we said this is, of course, y, this is x, this is r. And we said, of course, that sine theta, for instance, it is y over r. And cosine theta, it is x over r. Now, we can make it much easier by doing what? Draw this triangle on the unit circle. So what you will do, this is the triangle that I sketched, it is here. So just draw a circle with radius equals to 1, and then take this part now. Look at this part, here it is. Now, this is of course not a triangle, but of course it gives me all what I need. So now let's think about the triangle itself. Let's take this triangle, if you want to use the triangle. Now, ya shabab, according to that, this is y, this is x, this is r. But as you know, ya shabab, this is not on the unit circle here. This point, it is on not on the unit circle. So what we can do, we will take a point on the terminal side. Here, this is point, x and y. Now, what is r, ya shabab? What is this? What is this from here
The
to here?
radius.
What is it? It is 1. Do you notice that? Because it is unit circle. So what does that mean? So what will be sine? Sine theta, if you can sine theta, let's say t, because let's use the same notation. Sine t will be what? Will be y over r. What is r? R is 1. So it will be y. What does that mean? If we have a point, on the unit circle, then the y coordinate is the cosine, the sine of this angle. It is the sine of theta or t, because now t, the measure of t in radians, is the same as theta. And here we have, of course, cosine theta or t. So what we have indeed, we have this. If t is any real number, and this point is the terminal point on the unit circle. So it is the terminal point, or a point on the terminal side, if you want to think about it like an angle. If you want to think about it like an angle, here it is. But now we just make it much easier. Then sine t will be y over r, but r is 1, so it is y. What does that mean? The y coordinate is sine, the x coordinate is cosine, and tan, of course, it is y over x as before. Cosecant will be the reciprocal of sine, and so on. This is why, ya shabab, there is another name for these functions. Do you know what is the another name? Do you have an idea about it? The trigonometric functions. They have another name. They call it, in some textbook, they call them circular functions. Why they call them circular? Trigonometric, it is about the triangles. This is about, of course, circle, the unit circle. Find the 6 trigonometric. This is, of course, very trivial, ya shabab. What is sine pi over 3? It is still the same as we have before. So it is the same. So this is a repetition for 5.3 and 5.2 and so on. Notice that, of course, tan pi over 2 and secant pi over 2 are undefined. Why? Because tan will be sine over cosine, and of course sine over cosine, because cosine is 0. So tan pi over 2, it is sine pi over 2 over cosine pi over 2, which is, of course, 1 over 0, undefined. Or from here, طبعا, it is y over x. So 1 over 0 is undefined. The same values, ya shabab, the same table that I told you before. The same trick how to remember them. And the same, of course, angles. Now it is easier if you can put them with these points now. So now this is what you have. The x coordinate is cosine, the y coordinate is sine. So you can order them like this. And this, of course, if you are in the second, in the third, in the fourth quadrant. So this is the point, if you remember, that we have started with. In fact, it is just the point 11 pi over 6 on the unit circle. Now, what is easier, shabab, here for me for you also to remember? These are the reference angle. Now, pi over 6 is the reference angle for these 3 angles, and pi over 4 is the reference angle for those, and pi over 3 for the remaining ones. And what is interesting, and I'd like to mention, is these angles: 0, pi over 2, pi, 3 pi over 2. It is easier, shabab, to remember the values of these. So if someone asks you, what is sine 0? What is sine pi over 2? Mathalan, what is sine pi? What is sine 3 pi over 2? It is not difficult. Just draw a circle, a unit circle. Here, what you have, what is the point here? Because the radius is 1. This point, it is what? 1 and 0. This point here, it will be negative 1 and 0. This point here will be 0 and 1. This point here will be negative 1, 0 and negative 1. So here we are. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. Now here, for sine 0 is 1. And sine 0 is 0, because we are talking about the y coordinate. The y coordinate will be sine. Pi over 2, it is 1. Pi, it is 0. 3 pi over 2, it is negative 1. And you can do the same for cosine. Cosine is the x coordinate, and the sine is the y coordinate. The same is rule of signs يا شباب, all STC, all positive in the first quadrant, sine and cosecant in the second, tan and cotan in the third, cosine and secant in the on the fourth. How to find also the values, the same as we did in 5.3 يا شباب. How to find cosine 2 pi over 3? You need to ask yourself, in which quadrant 2 pi over 3? In which quadrant 2 pi over 3?
Second quadrant.
In the second quadrant. So because it is in the second quadrant, this one is in the second quadrant, what we will do, we will say that this is equals to what? Cosine in the second quadrant, it is negative. Cosine, how to find the reference angle in the second quadrant? We will just subtract this angle from pi. You know that the reference angle, what is the reference angle in the second quadrant? It is pi minus theta. So this is negative. Let me solve it here. This is negative cosine. This will be what? Pi over 3. It is expected that the reference angle is pi over 3. Minus what is cosine pi over 3? Cosine pi over 3 يا شباب. Cosine pi over 3.
It's half.
A half, يا شباب, it is the same as sine pi over 6. Okay, let's go here. Now, how to find tan pi over 3? Tan negative pi over 3. To find tan negative pi over 3, there are different methods. I told you about the at least 2 methods. One of them, to ask yourself, is this function even or odd? I will mention this in the next slide, no problem. Let me solve it by one way. Now, what is this angle? This angle is in the fourth quadrant. It is not, of course, positive. This angle, it is less than 0. It is not between, let me say it in other words, it is not between 0 and 2 pi. So we need to find what? The least positive coterminal. So we will say this is equals to tan. In the case of terminal and coterminal, it is the same. So what we will do, we will add 2 pi. So this will be equals to tan. This will be 6 minus 1, it will be 5 pi over 3. Now, in which quadrant this angle? Now, this angle is in the fourth quadrant, 5 over 3. So it will be what? Tan in the tangent in the fourth. Is it positive or negative? It is negative. Come on, guys. So it will be what? 2 pi minus 5 pi over 3. How to find the reference angle in the fourth quadrant? It is 2 pi minus theta. So we have negative tan 6. It is pi over 3. It is negative. What is tan pi over 3, ya shabab? What is tan pi over 3?
Root 3.
Again?
Root 3.
It is square root 3 of 3. Are you sure about that? You can check, ya shabab. It is sine pi over 3 over cosine pi over 3. This is what I do when I'm not sure, but you have to be. This is equals to sine pi over 3, which is what? Square root of 3 over 2 over cosine, which is a half. So this will be cancelled with this, and you will have square root of 3 over 1, which is square root of 3. Good, you're right. Okay. So I told you this is one way, shabab. There is another way that I will show you just in the next slides. Tan ya shabab is odd function. Do you remember what we mean by odd function? When we have odd functions, f of negative x equals to negative f of x. This is the odd function. So because of that, tangent of negative pi over 3 equals to negative tan pi over 3. So this is equals to negative, what is tan pi over 3? Square root of 3. It is much easier, shabab, if you use that. Let's solve the last one. Any question, shabab, so far, please? Let's solve this. What is sine 19 pi over 4? Now, you need to ask yourself, in which quadrant this angle is? Anyone knows? You cannot know, shabab, because this angle is not between 0 and 2 pi. This one is greater than 2 pi. It is greater than 2y. So what we should do first, ya shabab? Who can tell me? What we should
in the
do?
first quadrant, we need to subtract a couple
How
of.
to know? No. Wait. How to know that it is in the first quadrant?
We need to subtract a couple of
So
rotates.
this was my question. I did ask you at the beginning in which quadrant is. You should say I cannot decide before finding the coterminal. So your answer should be, we need first to find the coterminal, then I can decide after that in which quadrant it is. Okay. Now in which what we will do, ya shabab? We will find the smallest positive coterminal angle with this angle. What is it? So we will say this is equals to sign as the same, no positive, no negative, of course, in the case of the coterminal. Now what we will do, we will subtract what? Yeah, who said who talked before? What we will subtract?
It's me, Muhammad Sultan.
Okay, Muhammad. What we will subtract? We will
Subtract 2 rotates.
Is it enough?
No, 4 pi.
Why we didn't subtract 3 pi or 5 pi?
They are not like a full
rotation.
They are not multiples. They are not multiples of 2 pi. You are right. So we are subtracting 2 pi 1 time, 2 times, 3 times. So this is why we subtract only odd, even multiples of 2 pi. So is it enough to subtract 4 pi, ya shabab?
Yes.
Let's see. It will be sine 4 times 4 is 16. 19 minus 16 is 3. So this is 3 pi over 4. Yes, this one is less than 2 pi. Also, if you put here 6 pi, it will be greater than 19. So you are now right. Now you need to ask now yourself, in which quadrant is this? This is in quadrant
Second
number
quadrant.
1. In the second, ya shabab, n minus 1. Do you remember the trick, n minus 1 over n? So now this is in the second quadrant. Because we are in the second, sine in the second, is it positive or negative?
Negative.
Sine in the second is negative?
Oh, no, sorry. Positive.
It is positive, ya shabab. It is positive. So no need to change the sign. It is the same. And what is the reference angle for sure? It is pi over 4. Ya shabab, pi over 3, pi over 4, pi over 6. The reference angle, any multiples of these, the reference angle is pi over 6. بشرط انه طبعا there is no common factor between the numerator and the denominator. Okay? طبعا انت يمديك كمان تسوي خطوة هنا. تقول in the second quadrant ايش نسوي؟ We subtract the angle from pi. But for sure, I know from the beginning يا شباب that the reference angle is pi over 4. Here I know that the reference angle is pi over 3. This is sine pi over 4. And what is sine pi over 4? What is sine pi over 4? Ya Abdullah Salama. Abdullah. Are you here, Abdullah? Abdullah Salama, are you here?
Yes, I'm here.
What is sine pi over 4, ya Abdullah? What is sine pi over 4?
Okay. Pi is 90 over 4. I think
it is sine 45 if you want to convert it to degrees, but no need, ya shabab. What is sine 45 degrees? Yeah, Abdullah. Who can tell me, ya shabab, what is sine 40 pi over 4?
Can I try?
Yes.
Square root of 2 over 2.
It is square root of 2 over 2. Yes. Let me look. What is Abdullah's name? Here. So this is square root of 2 over 2. Excellent. Be careful, ya shabab. You have to know these angles. Otherwise, what we are doing? We are done, ya shabab, with this part. Now, this is the even odd part that I told you about. Now, look at this point, at this angle now, what we can call it, whatever you can call it, arc length, whatever. So it is a number. So look at the number t. What is the coordinates here? This is x, this is y. So what is cosine t? Who can tell me? What is sine t? What is it, ya shabab?
Cosine t is x.
and sine t is y. Excellent. What about negative t? What is cosine negative t? Look at this now, this number. Cosine negative t and sine negative t. Look يا شباب, when you have a point here, x and y in the first quadrant, if you draw or if you reflect this point here, it will be, x will be the same, y will be negative because we are in the fourth quadrant. Now, what will be cosine negative t يا شباب?
X,
It
just X.
will be x. And what is sine?
Minus Y, negative
What
Y.
we conclude from here?
That cosine doesn't put
Cosine.
That cosine t is equals to cosine negative t. Both of them are equals to x. And we conclude from the remaining part, from this, sine t equals to y, then sine negative t equals to negative y. So what we can say here, we can say equals to negative, this negative. What is y from here? Y is sine t. So we can say that sine negative t equals to negative sine t. This means that sine is of course odd function. This is to show you why it is odd. Look. Now we can generalize the shabab. What will be tangent, by the way? Tangent, you can do it from here. Tangent here will be y over x. Here it will be negative y over x. So it will be the negative. Or you can do it by dividing, of course, sine negative t over cosine negative t. So also tan negative t, it is negative tan t. What we can conclude from this, ya shabab, that sine, cosecant, tangent, and cotangent are odd. So we have 4 functions are odd, and only 2 functions are even. Cosine and its reciprocal, secant. Cosine and secant are even, and the others are odd. And this, of course, will help us now to simplify the expressions like here. This will be so easy now, ya shabab. No need to think about coterminal and so on. Just you will say sine is odd or even?
Odd.
Odd. So it will be negative sine pi over 6 equals to negative sine pi over 6 is what? What is sine pi over 6? Ya Ammar al-Harbi. Ammar. Are you here, ya Ammar? Ammar. Ammar is not here, is not responding.
Yes, doctor.
Yes, ya Ammar, what is sine pi over 6? يا عمار ما عندنا وقت الله يرحم والديك.
Actually, I don't know.
Okay, thank you. And remember your grade, ya Ammar, in one of the quizzes. Be careful, ya Ammar, please, please, please. Mahmoud bin Laden, ya Mahmoud, are you here?
Half, doctor.
I
Minus
didn't.
half.
It is what?
Minus half.
It is a half. Sine pi over 2 is a half. So easy, ya shabab. Now, what is cosine negative pi over 4? Similarly, it will be what? This one will be equals to what? Because this one is even, it is even, so just this will disappear. It will be as the same as cosine pi over 4. Because it is odd. Because it is even, I say. What is cosine pi over 4? What is cosine pi over 4? Ya Haytham Zahrani.
It's root 2 over 2.
It is square root of 2 over 2, and it is the same as sine pi over 4. Thank you, Shabab. Now, I think this is a recitation. I will skip this, but let me give you what about the time? I think we can, inshallah, finish this. We can manage it. Now, this angle, Shabab, this question, it is an old exam question. If this is f of x, and this is g of x, which one of these is true? F is odd, G is even. F is even, G is even. F is even, G is odd. F is odd, both odd. Here even and G is neither. What do you think? How to do that? So you can, Shabab, if you have a question like that, there is a nice trick that you should do. What is it? Start with the easier, Shabab. Which one is easier, this or this?
GX.
F or G? F or G, Shabab?
G.
G.
G. So now I will start with G. what is G? I'll try to simplify it يا شباب لأنه أنا عندي I can simplify it. What is tan negative x?
It is negative 10x.
So this negative يا شباب, it is as it is here. So this equals to what? Instead of, we know that tan of negative x, it is negative tan x. Why? Because it is odd. Tangent is odd. So here I will replace this, by negative tan x. Now negative times negative, positive. So what is indeed what is G? What is G? He just tried to make a trick. Indeed, this is G. G is tan x. So tan x is odd or even?
Neither.
Tangent odd. It is odd. So is this correct option?
No.
Is this correct option? No. This is a possible one. This is a possible one. This one is no. So now I cancel the three choices with just this choice. With this nice trick that I started. I started with the easier. Now the answer for sure it is C or D, one of them. What I need to do, I need now to check if. How to check that it is even or odd? Do you remember how to do that, ya shabab, from MATH001? You will replace x by what?
Minus x.
By negative x.
Negative x.
And you will say, this is negative x. You will replace every x by negative x over sine cubed, also negative x. Remember, ya shabab, that sine cubed is indeed sine to the power, all to the power 3. I'm talking about x. Okay, so what does that mean? Now here we will have cosine is what? Cosine is even, so it will be the same. So we will have here negative x cosine x. Why? Because it is even. Cosine negative x is cosine x over. Now what is sine? What is sine of negative x, ya shabab? It is negative sine x. Why? Because it is odd. Now when you cube, when you raise it to the power 3, what will happen? Negative 1 multiplied by itself 3 times, it will be negative
Negative 1.
sine to the power 3x. So what I write here, negative sine cubed x. Now I will simplify as much as possible. We still have one simplification. We have here factors, no addition. So negative over negative, positive. So we have x cosine x over sine cubed x. What is this? This is the same as the original function. It is the same as the original function. So what we can say about this? Even or odd or neither?
Even.
It is even. So which answer is the right answer? C or D?
C.
It is C. So the answer is C. Okay, Shabab? Now the fundamental identities are the same that we have mentioned there. These are the reciprocal, but here just we don't use theta. It is not necessary to use theta for any real number, not necessarily, of course, in the same notation, but it is the same. It is a matter of notation. You can put here x, you can put theta, you can put whatever. And these are the Pythagorean identities. These are also applications on them. If cosine t is 3 over 5 and t is in quadrant number 4, find the values of the others. What you will do? Again, Shabab, you will ask yourself what is x, what is y, and you can use, of course, the trigonometric identities in this case to find cosine and sine. I'll skip this because, of course, you can do it as we did before. Write tan t in terms of cosine. We did that, but in the previous class, we did write it in terms of sine. Now we will do the writing it in terms of what? Of cosine. So tan t, it is sine t over cosine t. And I want it in terms of cosine, so I will do just cosine as it is. Sine t, I know that it is positive or negative, the square root of 1 minus cosine square t. Positive or negative, what I will choose depends on the quadrant. He said in the third. So positive or negative, who? Positive or negative sine. Sine is in the third is what? Is positive or negative? It is negative. So this is not about tan, Shabab. It is about sine. What you bought, sine instead of what? This is exactly what we said, but of course, because we are in the third, sign is negative. طيب, who said يا شباب, let me ask you this nice question. Unfortunately, the time will not be enough, but it's okay. It is very important. في الثird يا شباب, في الثird quadrant, التانجنت positive ولا negative؟
Positive.
طيب وهنا ايش موجود؟ ايش رايكم؟ هل هذا بوزيتيف ولا نيجاتيف؟ احنا قلنا هذه بوزيتيف، ضروري تكون بوزيتيف. هل هذا الكميه اللي هنا بوزيتيف or negative؟ Is this positive or negative?
Can I answer, doctor?
Yes, please. When I'm
Yeah.
asking, not when I don't ask specific student, you can answer, no problem.
Okay. In the beginning,
Positive or negative?
it's negative. On the negative, it will be positive.
Is my question was clear, so easy. Is it positive or negative? And then I will ask you why.
Positive.
It is positive or negative?
Positive.
Is it positive? Why?
Because we have negative on the negative. That's will be
Negative over negative. Cosine is negative in the third. So negative over negative is positive. You are right, Hamid. Thank you. Now, ya shabab, these are the co-function identities, just to remind you about them. Also, there are nice identities that you can have from the circular, the unit circle. I will skip this and leave it for you. That when we add, of course, by, we go from the first quadrant to the third. So sine will be negative, cosine will be negative, tan will be also positive, the same. Now about the domains. I think I prefer to talk about this in the next section, but let me just spend the 2 remaining minutes on that, because we have quiz, ya shabab. Now in 2 minutes, we will go to quiz number 3, inshallah. What is the domain, ya shabab? Now, the domain of sine and cosine is all the real numbers. Why? You can find sine x and let's say sine t, or cosine t for any t, for any angle. But here any number, I will give you what is sine, because we are talking about all the real numbers. Now, for tangent and secant, we have a problem. We have, this one is sine over cosine, and this one, it is 1 over cosine. Here, if cosine is 0, these will be undefined. The same for cotan and secant, they will not be defined if sine is 0. So when sine is 0, ya shabab, sine, let me start with cosine. When cosine is 0, cosine what equals to 0? Cosine what equals to 0, ya shabab?
90.
0 or
There, cosine is 0.
90 or 270.
5 pi over 2. So the odd multiples of pi over 2. فببساطة احنا راح نقول انه cosine t equals to 0 if t is pi over 2 plus n pi. In other words, it is the same as 2n plus 1 pi over 2. This means odd number over 2, odd number 1, 3, 5, and so on. So this is why the domain of tangent and secant will be all the real numbers except these angles or these numbers. For sine t, when sine t is 0, shabab, sine t is 0, you can start to prepare now, shabab, but let me just finish this part. I will give you 1 minute, inshallah. We are ready now. Sine t equals to 0. What is t? What is the angle that its sine is 0? It is 0.
0, 2 pi.
By 2 pi, 3 pi, 4 pi, and so on. So it is indeed 0 plus n pi, which shortly can be written as n pi. So the domain of cotan and cosecant will be all the real numbers except the zeros of sine. We will continue this, inshallah, next class with the 6.3. It is related to 6.3 more than 6.2. Thank you, shabab, and see you, inshallah, tomorrow with 6.3. Now, let's move to